Hi, my name is Xin An, and this is a midterm 2 exam wrapper for question number 4. So problem number 4 says, you put a thin metal pot containing 2 kilograms of room temperature 12 degrees Celsius water on a hot electric stove. You also stir the water vigorously with an electric beater, which does 100 joules of work on the water every second. You observe that after 15 minutes, the water reaches a temperature of 100 degrees Celsius. The specific heat for water is 4.2 joules grams times Celsius. So we're going to make two assumptions here. According to the first law of thermodynamics, the delta E system is equal to the Q plus W, where W is the work and Q is the heat, and WE universe is equal to the WE system plus WE surroundings, which is also equal to 0. And then also we're going to say that delta E is equal to MC delta T. So for the first part of the problem, it says, what was the change delta E thermal in water? So we're going to use this equation saying that delta E thermal is equal to MC delta T. The mistake that I made in my exam was that I also included work, which is wrong. So if we just go by this equation, with our givens, we know that 2,000 grams is the mass. We have 4.2, which is the specific heat of water. And we have the change in temperature, which is a final temperature of 100 degrees Celsius minus 12 degrees initial in Celsius. And we find that the change in E thermal is 739,200 joules. The next question says, what was the thermal transfer of energy Q into the water from the surroundings? So we're going to use this equation, delta E thermal is equal to W plus Q. And the mistake that I made in my exam was that I used delta K instead of W. And I said delta K equals 0, which is completely wrong. So we're going to, if we manipulate this equation, we're going to get Q is equal to delta E thermal minus W, where W is equal to 100 joules times delta T, because the 100 joules that they give is the work on the water every second, where we need it for 15 minutes in order to reach the final temperature. So we're going to use what we have here, what we found in part A, this number, minus 100 joules times 15 minutes times 60 seconds to convert this into minutes, joules per minute. And we find that the answer is Q is 649,200 joules. The next question says, what was the change delta E surroundings? So the equation that I made was that I thought that delta E surroundings was 0 joules because no work was done on the surroundings, but that is actually wrong. We have to use this equation right here that says delta E system plus delta E surroundings is equal to 0. We also know that delta E system is equal to delta E thermal because of part A. So if we kind of manipulate it and plug in some variables, we find that delta E surroundings is equal to the negative delta E system, which is the negative delta E thermal. And we found that delta E thermal in part A was this number, except we have to put the negative because we're finding the delta E surroundings. The final question is, you take the pot off the stove and drop in 2.26 kilograms of sweet potatoes. The potatoes are initially at room temperature 25 degrees Celsius and have a specific heat capacity of 3.14. Determine the final temperature of the water and sweet potatoes once they come to equilibrium. You can assume that the pot is a very good insulator and does not change temperature, so we can ignore the change in thermal energy of the pot. So we know that delta E is equal to W plus Q, and we know that delta E thermal, we're going to say in this case, is 0. So delta E thermal of the sweet potatoes plus delta E thermal of H2O is equal to 0. And by this, I mean that the change in total delta E thermal is equal to 0. So we know that delta E thermal is equal to the equation MC delta T. So we plug in the respective numbers for the sweet potatoes and for H2O. And if we manipulate the final temperature, we know that they're going to have the same final temperature. So if we manipulate the equation to locate specifically for the variable TF, then we're going to come up with this. And if we plug in all the numbers, we're going to find that the final temperature for both the sweet potatoes and the water is 65.7 Celsius. Thank you very much for watching.